In this video, you'll find solutions to examples 1 and 2 from topic 1. Let's begin. Example 1 asks us to find the domain and range of the function x squared minus 3. This function is also graphed for us in our handout. Domain, as we recall, is all the x values a function can take on. We could think, what numbers am I able to plug in for x into this equation? We could also scan the graph and see what x values are being used. Keep in mind, this graph does go on forever, even though this is a small snippet of it. So really, there are no limitations. We can plug in any value. So in words, we might say, all real numbers. For the range, we're looking at the y values a function takes on. So if we look over here, maybe we consider how high and how low it goes, because remember, y values are what the range is made up of. So the lowest our function bottoms out at here is a -3, but our highest is a different story. These arrows indicate that that function intends to go on forever. So we would say the y values go from -3 to +infinity. In the next few slides, we're going to figure out how mathematicians write those answers to domain and range in specific formats. But for now, to finish off our question, we could rewrite our function y equals x squared minus 3. If you haven't yet watched videos on set notation and interval notation, or taken notes on them or found out how to do them yourself, you may want to do that and fill in those notes. But let's practice a few. Down here we see bracket 3, 4, bracket. That would say in words, including 3 and up to 4, including it also. You could say that many different ways, but that's what this interval notation represents. For set notation, you may have learned, we start with our ellipses. Generally, we have our x, and we use our inequality notation. So we would say 3 is the lowest number, is less than or equal to x, is less than or equal to 4. And close our ellipses. Let's try one more. We want to know all real numbers greater than or equal to 3. So any number will work. It's going to go on forever, but it has to be greater than, and it could be 3. So think about our lowest number. 3 is our bottom out number. 3 is the lowest number, comma. Our highest number is any number bigger than that. So anything up to infinity will work. Remember, infinity or negative infinity always get parentheses. 3 is included. Our answers can be equal to 3, so we will use our hard bracket. For our set notation, we first include our variable, and we use our inequality of 3 is less than or equal to x is less than infinity. Know that when I had my equal to, I had the hard bracket for the 3 and the underline on the inequality. But since the infinity is not included, or we can't reach it and a parenthesis is used, we have no solid line under our inequality. You'll want to finish this table, but those are a few examples. Check out the PDF for all the solutions. For part B, there's a picture. It's important to note there's actually a lot of information on this picture. We see an airplane dropping water over a forest fire, and the airplane holds 8,000 gallons of water. It's releasing 400 gallons per second. Keep that information in mind as we try to answer the following question. They want the domain and the range of some function that would represent the volume of water that the tanker can drop in x seconds. Now remember, that domain has to do with all the x values of a function. So in this case, the domain will represent seconds or time. So if we want to know how long this tanker can drop water, we realize this picture doesn't actually tell us that. But say you have a full tank of water that holds 8,000 gallons, and you're going to pour out 400 gallons per second. Since domain has to do with time, they're asking how long is this airplane in the air or dumping water. If you're going to pour out 400 gallons every second, how many seconds would we need? One way to do that would be to take our 8,000 divided by 400 to give us 20 seconds. So the airplane will be dropping water for 20 seconds. That means our domain will be from 0, because we wouldn't have negative time, so 0 to 20 seconds. That's our interval notation. Our set notation would be 0. Let's use our 0 first. So 0 is less than or equal to x is less than or equal to 20. Now for our range, we need to think of what our range or our y values are representing in this problem. Well, as time is going on, our domain values, what's happening? Well, we're releasing water. So the volume of water is actually our range. How much water do we have to release? 8,000 gallons. So from 0 to 8,000, that'll be our range. And our set notation is as follows. To finish off our example 1, we have the triads. We're given the function y equals x minus 4, or the absolute value of x minus 4. There is a video on how to graph absolute value, so check that out if you're not sure how to graph that, whether you're on Desmos or a TI calculator. But I have a handy dandy picture here. I've graphed the absolute value of x minus 4. Now they want the domain and range. And they want it in set notation and interval notation. We see our domain as what are the x values used in this graph. Well, since it goes on forever, if we scan across like we're reading a book, we see every x value across the gamut is used. So we have all real numbers. That means negative infinity to positive infinity is our domain. Now, to give us our set notation, we can use our inequalities, but what we're going to use, something a little bit easier, we'll say x is all real numbers. Now for the range, that's the y values, how high and how low it goes. We see it's going to extend forever. They're going to keep going on that absolute value, but it bottoms out here at 4, 0. It's very important that you use the y value where this is starting. So we don't really care about that 4. That's the x value. So we're going to say our range starts from 0 and includes 0, so a hard bracket, and goes all the way to infinity. Now for our set notation, we use our ellipses, we use our variable y, and we just know that y is greater than or equal to 0. Let's try another one. We have 6x minus 2x squared. Again, you would graph that and think of what x values are being used, whether it's on the graph or you could think of the equation as well. I scan the graph. I know that arrows would be used at the bottom of this parabola. They go on forever. So our x values are any value we might pick. We could plug in anything we want into this equation for x. So, not unlike many of the examples you'll do, our domain is from negative infinity to infinity. And again, our set notation is all real numbers. For our range, it's going down forever, but it does stop here at a y value of 5. So, now we do want to be careful actually. We should actually look at that. Probably not 5, because look at what they're counting with. Every 2 squares is a unit. So 1, 2, 3, 4. This is actually 4.5. So the mistake I almost made there, be careful. If you have Desmos open, you can always click on that top point. But it's going to be 4.5 as our top point for the range. So our lowest number is negative infinity, comma, our highest number is 4.5. And we'll use a hard bracket because it does hit that value. For our set notation, we would say y is less than or equal to 4.5. For example 2, we move into x and y intercepts. You may want to watch a video that's included on how to find x and y intercepts algebraically. We can also use graphs to help us as well. We have a car that filled up their tank of gas and they're traveling down the road. Y is the number of gallons in the tank and the number of miles the car has traveled is what x represents. They want to find the x and y intercepts of the graph of this equation and tell what they represent for this car. I find it quite helpful to use the graph and the labels that are on the sides to answer these questions. Remember, the x-axis is always the horizontal axis, so that'll be our domain, or the x values they're speaking of. For an x-intercept down here, we have 320. We need to know that 320 is one value, but 0 is another. For our x-intercept, the x value comes first. That means 320 will be first. What does it represent? It appears 320 miles would be how far the car can travel. Now, for a y-intercept, we see it's 16. This coordinate, I'll write down here, this coordinate would be represented as 0, 16. What does that tell us? The most amount of gas that car had in its tank was 16. So 16-gallon tank of gas. Odds are good we can travel that 320 miles there then on 16 gallons of gas. They also ask us, what are the x and y intercepts of another graph? Absolute value of x minus 3. Again, use your graphing tool to look at that. And as we check out the graph, we see that it crosses the x-axis 2 separate times. Again, watch the scale that your graph is counting by, because it's using 2 squares for each unit. So we'd have 1, 2, 3 on the right, 1, 2, 3 on the left. So our x-intercepts in coordinate form will be 3, 0 and negative 3, 0. Our y-intercepts, just y-intercept rather, is this one at the bottom, negative 3. Notice how 0 comes first this time for the x value and negative 3 second. As mentioned before, there is a video on how to find the x and y intercepts algebraically. You may want to look that up and put those in this portion of your packet. But let's use the triad to show the examples. I'm actually going to use the space above for my work down here. I'm going to start with the y-intercept. To be honest, it's a little bit easier. If you've looked at the notes or you remember, the y-intercept is when the x value is 0. So if I put 0 in for x into this g of x equation, that means I'm going to put 0 where x is. Well, 0 squared is 0, so I get 4. My y-intercept is x0, y is 4. You could graph that to verify this same information. For the x-intercepts, you get to remember something pretty fun for this. The x-intercept is when the y value is 0. So I will replace this g of x with an actual value of 0 and set it equal to 4 minus x squared. Now, to solve this, I'm trying to think, what number could I put in for x that would make my equation become 0? You may be thinking, hey, if I put 2 in there, 2 squared is 4, and 4 minus 4 is 0. That's true. 2, 0 is going to be one of our answers, and the x-intercept will be 2, 0. But there's another one, and if you graph it, you would easily find it. What about a negative 2? A negative 2 times a negative 2 is a positive 4. And if you subtract that from 4, you'd also get 0. But algebraically, that wasn't algebraically, that was guess and check in my head. So, to solve this, we're actually going to set up factoring to find the 0 of this function. 2 times 2 is 4, x times x is x squared, 1 will be negative, 1 will be positive. If you factor, you're able to better see what numbers could plug in to make the equation 0. For example, 2 minus what value would make 0? Well, that'd be 2. 2 plus what number would make 0? There's our negative 2. So we would say our other intercept would be negative 2, 0. And there you have both x-intercepts for that parabola. You'll check out the next video for examples 3 and 4 in topic 1.